All right, 5.6, rates of change in rational functions. The average rate of change of a rational function, y equals f at x, on the interval from x1 to x2 is the following: f at x2 minus f at x1 over x2 minus x1. Now, what I'm noticing is that a lot of you are just memorizing this formula, but not really stating what it equals to. So what I want in the beginning is one of the following two. If it asks for average rate of change, please write average rate of change equals this. If it asks for slope of the secant, say slope of the secant equals this. If it's something else, whatever it is, it equals this equation, and then you plug in the values. What's important to me is that you plug in the values and you show me that you a level of understanding. All right, next. The instantaneous rate of change of a rational function, y equals f at x equals a, can be approximated using the difference quotient. We can use the difference quotient, which is as follows, and a very small value of h. What we're standardized to use to is that h equals 0.001. Now, what do we put in front of that? Well, it depends on what the question is asking. If it's asking for us to find the slope, put this in. Or put this in. Or if it says the slope of the tangent, put this in. Average rate of change equals. It depends on what the question is asking. So please, folks, make sure it equals something in the beginning, because that shows me you communicating your understanding. Let's move forwards. The instantaneous rate of change at a vertical asymptote, note, is very important. It is undefined. It's undefined. Think about it. The slope of a vertical line is undefined, and the slope at an asymptote is undefined because the function doesn't exist at that value. Also, the instantaneous rates of change at points that are approaching a vertical asymptote become very large positively or very large negatively. And what that means is that as you think about a slope of a line, as it approaches a vertical line, the slope gets steeper and steeper. The positive or negative indicate direction of the steepness. The value that as it gets closer and closer to a vertical line, what we're looking at is a very, very large number very, very quickly. So the number itself will get very large very, very quickly. The sign, again, don't forget, indicates direction. Also, the instantaneous rate of change near a horizontal asymptote approaches zero. That is also true at a turning point. So the idea is that as it approaches a horizontal asymptote, you're thinking about the function is literally approaching a horizontal line. Horizontal line has a slope of zero. And that is also true when you have a tangent line that is directly on a turning point. All right, let's move forwards. Example 1. Determine the slope of the line that is tangent to the graph of each function at the given point. Then determine the value of x at which there is no tangent line. So, we're actually going to answer that second part first. The second part says determine the value at which there is no tangent line. Where, folks, is there no tangent line? Hopefully, you're all thinking, oh, a vertical asymptote, there couldn't be a tangent line. So what is the vertical asymptote here? That will be x equals 5 over 3. X equals 5 over 3 is a value at which there is no tangent line. All right, so let's do the first part. Determine the slope of the line that is tangent to the graph of each function at the given point. So here's our point. We need to find the slope of the tangent line. All right. So here's our equation. And we're going to sub a equals -2, h equals 0.001, into delta f over delta x is equal to the difference quotient. Plug in the values for a and h into the equation. Now, what's important here is f at a. What I do sometimes is I like to calculate f at a separately. So here's my f at a. I get this value. That's the value I'm going to plug in right into here. So we plug in f at a, and don't forget that the first part has to equal this, which is the two parts, the numerator and the denominator, and then minus f at a, this is my f at a, all over 0.001, and we get values of 0.2809. Hopefully what you're thinking here is, okay, what am I seeing here? Well, this means that at -2, we're getting really, really close to something which involves a slope of 0. Because it's a very small number, in fact, we're going to get closer and closer to 0 as we get closer and closer a certain direction, or it could be coming close to a turning point. Either way, that's what we have going on here. All right, and that's it. You should know how to do instantaneous rate of change and average rate of change because we've done this we did it for a whole unit, and we've done this is now the third time we're looking at this particular value in a different unit. All right, hopefully that helps. Take care, folks. Good luck on your test.